Hello and welcome. My name's Hite. Thanks for stopping by. This video is about how to make wind chimes and the decisions that will be useful in adding your creativity and ingenuity to the design. A set of wind chimes is really very simple. You can add to it your creativity for how you support the chime, the type of tubing you use, the size, the line you use to support it, the striker, and the elements in designing that, along with the wind sail. So before we get started with the construction techniques, we need to make some decisions about the type of metal and the notes and the length. And now we'll go to the computer and figure out the lengths for the tubing. While we're there, we'll also figure out the proper diameter for the striker. In addition to that, we'll determine the proper layout for the chimes on the support plate, the distance between them, and the sequence of chimes in the circle. So before we can go to the calculator, one of the questions most often asked from the website is what metal sounds best? And the answer is they all sound good. As long as we properly support them and properly strike them, all metals sound good. And I've got a little demonstration set up here where we've got 5 different tubes, 4 different metals. I've got an aluminum tube, a titanium tube, a steel EMT referred to as conduit, electrical conduit tubing. This is galvanized steel pipe, and this is just copper or water pipe. And what I'm going to do is go down and strike each one. They've all been cut for the musical note C4. So just notice that they all sound very similar. I'll point out some differences after we do this. So here we go. We're going to start with aluminum, which is the least dense, and I'm working from least density to the most density. With copper being the most dense, and then we work on down from there. So as we strike these, you'll notice that they all sound pretty much the same. They're all cut for C4. And we'll do it again. So they all have pretty much the same sound. They're all precisely cut and tuned for exactly C4. There's slight differences between them, and the differences has to do with the thickness of the wall. I want to point out the differences between these two tubes. This is electrical steel conduit and this is galvanized steel. Different wall thicknesses. This is a normal thickness of EMT conduit, 5/8 inch, and this is 1/2 inch galvanized steel pipe. And listen for the sustain time. You'll notice the galvanized steel pipe has a much longer sustain time. It has more mass, can hold and release the energy much longer. So in a quick look-see at the type of metals, some of the concerns would be the economics. What does it cost? Titanium, of course, costs more. Aluminum is lighter weight, and so the weight of the chime set might be an important factor. If it's not, galvanized steel pipe would be the heaviest, but might be the better choice. And in some case you may have some scrap copper, or you want to use copper chimes for the aesthetic appeal. So properly tuned and properly supported, they're all going to sound quite good. So to begin collecting your resources that you'll need for design and construction, go to the website and scroll down. You can download pretty much the entire website in this handbook here. Here you can download plans for a chime set that uses chrome-plated shower rod curtains. Very economical and very good sounding set of chimes in 4 different sizes, and all of the measurements are included in these plans. If you're designing your own, you'll need a support disc and a striker, and you may need some cutouts for the wind catcher. So scroll on down to the chime length calculators, and in our case we're going to use the musical notes from the C9 chord. So download this calculator here, the C9 chime tube calculator, and also download the support disc calculator if you're not going to use a predetermined pattern. On the other hand, scroll down a little bit more, and we have a set of pre-calculated chime tube dimensions. Click on that and it will take you to this chart where you can select the type of metal, aluminum up here at the top, or copper, or brass, or steel, in various different sizes here. So say for example you wanted to use 1 inch aluminum with a wall thickness of 0.05, you would select here, download that chart, and you have a set of predetermined lengths. To use the calculator is very simple. You need either Microsoft Excel or the Excel Reader. Excel Reader will work just fine. We're going to enter 3 parameters, the inside and outside diameter and the type of metal. So in the case of these titanium chimes, we'll click here on the outside diameter and enter 0.625, and the inside diameter is 0.555. And click on the metal tab that now says aluminum, pull down this arrow, and we'll select titanium. And as soon as we do that, the calculator's done. We're going to select the C5 chord for our chime set, and I'll highlight it here. You can either copy this and paste it into a Word document or print out the entire sheet. But what we have are the 5 notes listed here, the length of each chime in this column, and the point at which you drill the hang point in this column in inches. The orange is in inches, yellow is in millimeters. Also at the very bottom of the chart is a handy calculator to convert between English and metric. You enter the English value here, and it'll give you the millimeters, or the metric value here, and it'll give you the inches. Also, in case you didn't happen to notice, at the bottom are 9 other tabs. One tab is for a ratio calculator that you do not have to know the specific inside or outside diameter, but if you know the outside diameter and the note that it chimes at, you can ratio that to other chime lengths. In addition, there's a tab for the engineering data that's used to make the calculations. Also a tab for the musical notes with their associated overtones 1 through 4, and a series of tabs with the standard dimensions for the various metals. Also, you may want to use your own design for a top support plate rather than using a predetermined pattern. For that, we have a support disc layout calculator. The steps are listed here that you need to complete in order to use the calculator. The calculator will give you the outside diameter of this disc. It will give you the diameter of the striker, this blue circle here. Also will give you the location of the chime centers. Here in this example, it's a 5 chime set. It'll give you the center to center distance, and you mark those out, and they will be equally spaced 5 points around that circle. We're going to use the calculator using inches, so we'll use the orange area in this column. We're going to ask for 5 chimes. Through the pull-down menu, you can select the number of chimes. You can select the outside diameter of the chime, which in our case is 5/8 of an inch. We're going to ask for a 3-inch diameter striker, which is 1.5 inch radius. And we're going to ask that the chimes be separated from the striker by 1/2 inch. Once you enter those parameters, then the answers in inches are in orange down here. 3 parameters that you selected are in blue, and the 4 calculated values are here in red. And when we get to the shop, we'll explain how you use these. Now that we're done with computer work, we can begin construction, and we've got the printout, all the dimensions and layout patterns that we'll need. We've got the length for each of the chimes, along with where to drill the hang point. We've also got all the dimensions for the support plate and the striker and how to lay that out. Of course, we'll need to cut the tubing. If you have thick-walled pipe, like steel pipe, hacksaw blade, or a chop saw works good. Thinner wall tubing, a tubing cutter, of course, works good. If you have a metal cutting blade for the chop saw, of course, use that. A few files will be handy. I have a round file that we'll be using to deburr the inside of the chime, along with a half-round file for the inside of the chime, and a flat file for the edge of the ends. It's handy to have a lighter handy. For our set of titanium chimes, we're going to be using braided 50-pound fishing line, and it's a much cleaner cut if we use a flame to cut it rather than side cutters. We get a very nice, clean, trimmed edge that way. Of course, we'll need some method of drilling, either a hand drill or a drill press with the appropriate size drill for the hang point hole. In addition, we're going to need a section of coat hanger wire with a 45-degree bend on the end, and I'll show you later how to use that to deburr the inside of the tubing. And we've got the diagram for the layout of the support plate in addition to the strikers. We got 2 choices for strikers, a circular striker or a star striker like this. And we've got the location, the center point for each of the chimes, and the 2 support holes right here for the lines that support the side of the chime if you choose that method of support. For measurement, I use a tape measure that has both English and metric. That comes in very handy. We'll need a set of hardware. You can either buy kits of hooks like this or individual hooks based on your choice for how you're going to support the chime, maybe an eye hook of some sort. It's important to hold the striker plumb and level so that the wind does not blow it askew. And for that, I like to use a turnbuckle. You can thread it through the striker like this. It provides a hook on the bottom to connect the string for the wind sail, and a hook on the top to connect to the top support plate. If for some reason you're not going to use the pattern for the layout of the chimes and the striker, it's handy to have a compass handy, because we have the dimensions on the location between each of these chime centers and the location for the holes on each side of where you'll drill the support line. Also, you need a little strip of paper. We'll show you how to use that later. And for the most part, this is the complement of tools that we'll be using. Whether we're using a hacksaw blade to cut it right here, or if we're using a tubing cutter, we want to position it just about 1/8 of an inch beyond the mark, put the knife edge right there, and tighten it up. If you've never used a tubing cutter before, you tighten it up thumb tight, and then rotate it, and then on every rotation give the knob about a 1/4 turn, and keep doing that. And after a few turns, it'll cut right off. Now we need to dress up this edge, and now we'll make an exact mark where 25 7/16 is, which is right there. And now we'll go to the bench grinder and grind this to the final value. Whenever we use a power tool, we need to take caution to protect the surface of the chime tube. In this case here, we put a couple layers of tape on the surfaces for the bench grinder to keep from scratching the tubing. In the case of the bench grinder, there's two ways to dress up the edge of the chime tube here. We can go straight on and rotate the tube like this as the wheel rotates, or we can come around here to the side. I happen to like to use the side of a grinding wheel. It's a good idea not to put a lot of pressure on the side of the wheel, but light pressure is okay. To protect the edges, I've taken some 1/4 inch aquarium tubing and cemented it around this metal edge so that when we lay the tubing on here, we're protecting its edge. And that way we wind up with a nice plumb and square edge. And if you don't happen to own a bench grinder, a flat file will work just fine. Lay the chime on a towel on a surface, and then just rotate the chime back and forth as you file the edge of the chime. Then we want to round over this outside edge, and we'll do the same thing, just rotate the chime and file it away. And now we need to smooth up the inside edge, and we can use a round file or a half round file and just clean up the edge on the inside, or you can use a half round file and again rotate the chime back and forth and clean up that edge in there. So when we're all done, we have a very smooth outside edge and a very smooth inside edge, so that any support line is not abraded by coming in contact with it. Just a quick reminder that anytime we're using power tools, make sure we wear the appropriate eye protection and hearing protection. Okay, we're ready to mark the hang point, which is right here. Because the tube is shiny and hard to see, I'm going to wrap some masking tape about where that mark goes so that I can accurately mark the location. We'll put an exact mark for 5 11/16, which is right there. I'm going to take a metal punch and mark an exact spot where one of these holes will be driven. And it's important that that hole go directly through the center of the chime. An easy way to accomplish that is if you happen to own a drill press and a V block, you just position the drill on the V, and then when you drill through the chime, the drill will automatically come out the other side exactly opposite the entrance. If you do not own a V block, how do you get this exact same mark on the other side of the tubing? And I'll show you a little trick here that works very well in this situation. Now we want to move this mark to the exact opposite side of the tube. We will use our cigar band marking technique here, which is to wrap this paper around here and then put a mark right here on the paper where we punched the hole, and then slide it off. Then take that mark and put a crease at that mark and then squish the paper so the crease at the other side is it. Okay, and after we have that crease in there, in case you can't see the crease, you put a little pencil mark on the crease. Okay, we're slipping the cigar band mark back on the tube, and we'll position the pencil mark right over that little hole that we previously punched, which is right there. Holding the paper tight and the tube tight, you just turn it over and mark the exact same spot on the other side, and now you have a plumb and perpendicular mark on both sides of the tubing in order to drill a hole. Holding the tubing very steady with one hand, we're using a 1/8 inch diameter drill bit, and we're going to drill the support hole. Okay, there's one hole. We'll flip it over to the other side. Now we have holes exactly opposite each other, but now that we're done drilling the support holes, we have to clean up those holes and deburr them. Otherwise it will cut the support line as the wind moves it back and forth. Here you can see a fairly serious burr at this hole, and there's an equal burr on the inside of the hole also. So how do we get rid of that? The easiest solution is just to take a larger diameter drill bit and by hand put enough pressure on there and rotate it slowly, and you can remove that burr just like that. Now it's nice and smooth on the outside, and now we have to do the inside. And the first thing we want to do is take a long file and reach down into the chime. We position the hole very close to the end for purposes of demonstration, but on a real chime it will be way down in the chime. You want to take a long round file and just file off the inside burr like that. Even though we have removed most of the burr, we're still left with a sharp edge on that inside hole. How do we get rid of that? The easy solution is to use this coat hanger wire with a 45-degree bend about a 1/4 inch long at the end. It looks like this. And you place that inside the chime like this. So it looks like that, and then as you rotate the drill and pull backwards, it will smooth out that edge and bend it over. Now it's very smooth in there, and it has bent over any sharp edge, and so any line going through there will not abrade. Now that we have all of our tubing cut to length and the ends have been deburred and the support holes have been drilled and deburred at the proper point, 22.4% down from the end, it's time to begin threading the chime. There's a few techniques you can use here. For this set of titanium chimes, I'm going to use 50-pound braided fishing line. It doesn't show up real well on camera, so I'm going to use a heavier line just for purposes of demonstration. With a little bit of practice, you can thread the line straight through the hole and pull it out the other side, and you have the chime strung the way you would like it when you're doing a 2-point support like this. If for some reason you cannot thread it all the way through, there's another technique you can use here, and that is take your line and cut it into 2 sections like this, and then take one line and push it down and out the other end like this, and take the second line and push it down like that. Then tie a knot in this end and pull it back inside, and now you have the chime supported the way you normally do it if you threaded it straight through. If on the other hand you want to bring the line out the center of the chime, it works good for large diameter chimes. I would not recommend it for small diameter chimes, but you can put a pin through that support hole. After you have your pin installed, depending on the kind of tubing you're using, if it's copper you could solder it and file it off and make it very smooth. In other chimes you may have to epoxy it in and then file it down and make it very smooth and not mar the rest of the chime. But once the pin is installed, then you can thread the line down on the bottom side of the pin, bring it out the other end, flip it over and thread it down the back side, and it will catch and pull on that pin. So that's using a center pin for support. Another technique is to take this length of line that you want to use and thread one end just till it comes out the end, turn it over and push this, and so it comes out the other end. This is what I call a half wrap, and the line will wrap halfway around the chime tube. That's what I'm going to use for this 50-pound braided fishing line. When you bring the line out the center of a chime, it's important that you tie these lines together. Tie a knot right at the top of where it comes out. That's to keep the line centered so it does not touch the sides of the chime, which has a tendency to diminish the sustain time. Sometimes it will completely kill a chime. Then you can use this as a single support. We're now ready to lay out the striker. We have 2 choices. We can do a circular striker or a star striker. In my case, I'm going to select a star striker for this particular chime set. To get the correct pattern, you can download a whole package of patterns from the website that will give you the shape of the center striker or the star striker in relation to the chimes. It will give you the center point for the chimes based on the chime diameter, and if you're going to support it at the center of the chime, here's the support point. If you're going to support it with lines on both sides, here are the dots for the support on either side of the chime. In this case today, we're going to use the support plate calculator. We've inputted that we have 5/8 inch diameter chimes, we want a 3-inch diameter striker, and we want a separation between the chime and the striker of 1/2 inch. It comes back and tells us that we need to make a circle, this outside circle, 2 5/8 inch in radius. We'll draw that circle. And then the chimes are going to be located on a different circle called the chime location circle, and that turns out to be 2 5/16, so we'll draw that circle. Now at this point we're going to just select an arbitrary mark right there, and the distance between chime center to chime center is 2 11/16. And we set a compass to that distance, and we'll walk a mark around. We'll put a mark there and a mark there, and then continue that mark on around till we have 5 equally spaced points, and you'll see they all came out equally spaced. And so these will become the chimes, the center for our chime, those marks right there. You might want to put a punch mark at each of those locations. In our case, where we're going to center support the chime, we're all done. If on the other hand you were mounting the chime with lines coming out both sides of the chime, you need 2 support points for that. The calculator gives you that distance, which in this case is 1 inch and 11/32. So we'd set the compass and then just put a mark either side of the center, and that becomes the points where we drill a hole for the support line, and just keep doing that the same all the way around. And at that point we're done. We have the cutout pattern. We'll cut this out and mount the screw eyes at each of these and start assembly. And now that we've got all the components done for the chime, let's talk about some of the options you have for assembly. We've taken the support plate with all the properly laid out 5 support points and attached it to the bottom of this little birdhouse. We've done what's called a top alignment, and because the camera angle, it doesn't exactly look that way, but I have a pencil here to show that they're all evenly aligned at the top. And I've removed the pencil, and I think you can see this little knot that are tied up in here. We've used the half wrap method and brought the line up the center of the chime, and we tie a little knot right here at the top to force that line to be centered in the chime before it comes up and connects to the support point. So now we want to look at where we position the striker. We've selected a star-shaped striker so that it more equally strikes all 5 chimes together, and we positioned it so that the shortest chime is just below the level of the striker. It's got about another 1/2 inch to go here. And striking it in this manner assures that we are not striking the dead center of a chime. Dead center on a chime is a quiet zone. The good news is it's a very narrow area, so it's pretty easy to avoid. Coming down here is the ideal strike zone is either end of a chime, and we're selecting to strike at the lower end of the chime down here. We've used a turnbuckle for the axle of the chime, and you could just as equally put a circular striker in here. We've chosen a teardrop, and we want to position it just below the longest chime so that the distance between the sail and the striker is as short as possible. We want to maximize the amount of energy transferred from the sail to the striker, and we do that by a short distance. So here's our finished up chime set hanging out in the backyard, and very light breeze today, but one of the things you'll notice is that the wind sail is not moving very much. We're getting a slight movement in the star striker in a very light breeze, and which is another reason to use a star striker, is it will maximize the amount of energy transferred into the striker from the wind sail. And I particularly want to thank a company up in Canada called Titanium Joe for graciously providing these titanium chimes. I think they worked out very, very well. I just wanted to quickly show that chime set that you can download and build for yourself, made out of chrome-plated shower curtain. Again, we're using top-aligned chimes with the striker down just above the shortest chime at the bottom. In this case, we have stretched a rubber band around the striker in order to mute the sounds occasionally from high wind activity here. I want to quickly show this next set of chimes, which is made from 3/4 inch copper pipe, available in home improvement stores. And the longest chime is cut for C3. It's a 5 chime set using the C9 chord, with C being cut at C3. I wanted to point out this special striker that we're using. In a long set of chimes like this and high winds, they tend to bang and clang against each other and become really quite annoying. There's an easy way to quiet those down and still have a very pleasant sound. It's something I call the keeper striker. It's a mirror image of a star striker where we capture the chime and prevent it from going to the outside diameter. And the striker has a tendency to rotate back and forth. Even in a heavy wind, this will be a fairly pleasant sound. Also, we have a much better probability of striking all the chimes in the chord at about the same time. Also, I want to point out one quick tip. Whenever you're putting end caps on copper tubing or any other tubing, it's important that you attach them all the way around. In this case, we sweated solder down inside and made sure it flowed the entire circumference. In other cases, you may be using epoxy, and make sure it covers all the surfaces. If it only covers a couple of the surfaces and there's air gaps in here, this chime absolutely will not resonate. So if you wind up with a dead chime, from an end cap, take it off and reconnect it and make sure it's coated all the way around on the inside. It's a very convenient and easy way to support a copper chime. I want to take just a moment here to answer one of the consistent questions off the website, and that is I've calculated and cut a tube for C2. However, it doesn't sound like C2. Why is that? And the reason is I refer to a chime as naked in that it has no amplification help compared to a string instrument that has a sounding board like a piano or a guitar, or a reed instrument, a brass instrument that uses a reed for the sound generation. It has a transformer that transforms the impedance of that reed out to the atmosphere. It's called a horn, and that will provide the amplification. A chime, on the other hand, is naked. It has nothing. It has the circumference of the tube as the largest radiating surface. So when I strike this tube, we're not going to hear C2. Even though it's a 3/4 inch copper tube cut for C2, it's going to sound like this. Very good sustain time, makes a very good chime. But we're not hearing C2. However, C2 really is there. If you touch the chime to kill it, you'll feel that low frequency vibration. C2 is around 60 Hertz. Also, we can show that it's really there by putting the microphone very, very close to it, and you'll hear this hum. It sounds like hum on a microphone around 60 Hertz. But if I hold the microphone out here, you do not hear that hum. So the summary is, if you want very low sounding chimes, go ahead and make them long and also make them large in diameter. If this were a 3-inch or a 6-inch diameter chime, it would begin to radiate more of the lower overtones. It would start to radiate the first overtone, do a much better job at the second overtone, and it'll radiate a little bit of the actual fundamental 60 Hertz. You'll start to hear that a little bit. So it takes a very large radiating surface to transmit these low sounds. It'd be very similar to a woofer, a large speaker, and a sound system. You need to move a lot of air in order to transform those low frequencies out to the air. And you can do that with large diameter chimes. So on small diameter chimes, we're just not going to hear the fundamental, but it will be very melodious and sound very good.